Old man PHP. I create PHP video tutorials for you guys who want to learn a new skill and compete with the young crowd. This is video number 113. So in this video, I just want to discuss the key factors for choosing a data structure. Um, I will not be showing examples, but I will discuss here the types. And if you bear with me, um, it's going to be a little long because I'm going to be typing some stuff. And what I'm be talking about is the the big old notation that we have been doing for like 2 videos ago. And so the big old notation, and I wrote it down. Let me see, where is it? There's a picture right here, big note. The big old notation. See, you have, what is it, 1, 2, 3, 4, 5, 6, 7. 7 key factors I'm going to discuss. And I want to expand on the most common time complexities, right? From the latest to the more like the fastest to the slowest. So I took the liberty of creating a file, and I kind of wrote it down already, a lot of this stuff, because I didn't want to type all these things, because I'm going to put this in the description below, so that way you can, just grab it and yeah, okay, right here, 7 complexities, right? And it's supposed to be fastest, fastest to slowest, and you got your O1. Let's see if I have it here. Got your 1, your log on n, you got your on, you got your on log n. I know you're looking at this and say, what the hell is this? It's the same thing that happened to me, I think, about learning this long time ago, because I was just the type of guy who I drew the whatever I wanted to accomplish on paper, and real quick I just started breaking it. Don't get me wrong. I went through the whole process. Oh, you gotta create a design. You gotta do the wireframing. Because I was a one-man wrecking machine. I always used to say I did everything full. I'm a full stack person because I did the, using Adobe, Illustrators, Photoshop to get my stuff, wireframing. I mean, I did it all. Really, I really did, and even the manuals and the stuff. But as I started to concentrate on PHP, which I really love, first it was JavaScript. I know you heard it before. Then PHP. Then this thing about the old complexity, I'm like, what the? And it's just a calculation, So the first one would be this one, the constant time. So let's see what I wrote here. See, we have the ON. That's what you just saw. See the constant time. You see it right here. Performs a fixed number of operation, execution time, and it doesn't depend on the input size. So it doesn't matter if you do 10 to a million. It's fast. Those are fast. And he said, well, on the other video I mentioned, oh, well, but how do you explain it? What happens is when you do this and you're doing the calculations and you're doing your for loops and stuff, because it's mostly for like for loops and stuff that you're going to be using. It's your algorithm that's gonna slow us down, because there's ways of using data structure. In other words, if you don't need to use array, you might want to go for the tree. They might go for the stack. I know. I mentioned this in the other videos before. Don't worry, I'm gonna break them down more as I come in. I was just trying to throw these descriptions and what it's about, because I had to look up a lot of these things when I was a long time ago, and I remember having a thing that I sat down with some people who were expert at this and was explaining. These are my notes. So then I decided, okay, start, now that I understand, I'm gonna pass it on to you guys. So on the first one, right, it's the O1, right? That's performance number. We mentioned that. Then you got your logarithmic time. Every step reduces the problem size by a constant factor. Then you got your ON, that's the linear time. By the way, all this is also, because right now I'm discussing time, but you also got space, like in memory. What does it take? It's going to take up some memory, because you remember when you're using up a lot of memory, it costs money. So that's why you got to find the right one that will work. And basically, you're not using this in your algorithm. It's just that using your algorithm. But when you're going to describe or talk to somebody about it, you write it down on the board. You say, no, this is an ON, or this is an O. It's one of those type of things. So this is too much space here. Let's see, make it even much better for you guys to read. I was in a hurry to type this stuff out. I was gonna do. I'm sorry, guys. Only had like 5 hours of sleep. So then you got your O log n. That's the which I just described. Then you got your ON. This one is also fast, but the n could be any number of things, right? So the running time grows proportional to the size of the input. That's what I wrote down here. Then you got your ON log n. That's the linear arithmetic time, also described as the log, which is, where is it? Right here. Splitting, like the linear merging. It has a log n factor, repeatedly splitting, and in the input. And the n is the factor, processing the merging of the pieces. And it's like taking, wrote down here, it's like taking the n part and the log n part and the on part to make the on times the log n. I know this sounds foreign. It sounds like this came from space. Don't worry, it'll make sense later on. Oh man, I'm sorry guys. And you got the quadratic time, so the number of operation that grows proportionally to the square of the input size, and the number of elements equals n, and the operation equals to n times n. And then you have your ON this one was the ON2, that's because that's a square. Now this one is the O2n, and that's the exponential time, and used to check every possible combination, generate or subset of a set, and this becomes a manageable to work with. Then you have your ON. This one I wasn't too sure about. I had to look it up. Factorial time. This is for graphs. And this tries every possible arrangement of a set of elements. Excuse me. So, like, I don't know, like, the only example I can kind of come up with is like, let's say when you're doing the ABC, the combos, and especially when you're doing the searches, right? So when you're searching, it has to look for these combos, and you're doing the algorithm will check. It will say, okay, I want to check, is it this one? Because let's say I wanted to do ABC, it'll search, oh look, it found ABC, but it also checks for a what a CB. It does what would one be? AC, then that one. What would be the combo? This reminds me of a time. A cab. It's not a cab. It's CAB. It's just the combinations that it creates. CBA, like that. I remember one time that I had to do a quick there was a door that I had to get into, but it had these little locks where you have the Roman numerals and you have to kind of press these little black buttons. Yeah, you know what I mean? And I wanted to have, it had like 3 or 4, I forgot what it was. Maybe it was 5 of them. And what you do is you hit the same combo, but I didn't know. I didn't know what the combo, what it would be. So what happened was I took the actual thing that I read from the actual dial. It says, oh look, it has that's a 1, 2, 3. So what happened was I created, because sometimes when you're trying to get something quick, and you're like, oh man, I'm in pressure and I gotta get this thing up. So I mean, just for a little moment, I did a quick for loop type thing, and I did a combination. I did that for a lotto thing too, man. But anyway, I did a combination, and kind of like this, you got your ABC, you got this combination, but then what I did was, once I listed up, I used each one of them to see if that was the password to get in to this one door. And I was, that didn't work, so I know I tried this one, but at least it's this, because sometimes when you're trying to do this, you're not going to remember, but if you have it written down, and then what happens is it created this for me, and that's the factor of times, that we use it, but now the space, you can keep that there just for, in case you remember what I was just talking about. Now you got your space complexities. I should have typed this stuff out, man. Should have looked it up and typed it out. So the big O, right, deals with memory, right? So I'm gonna put down this here. I'm gonna say right here, memory, right? And so how much extra memory your algorithm uses in addition to the input itself, right? So it comes from temporary data structure like I'm going to, I don't know, maybe I should just say, maybe I should just write this up because it's going to be confusing. What was I, let me see. Okay, how much memory, that would be a better deal. How much memory your algorithm uses in addition to the input itself. Don't worry, I'm gonna make sure that if I make a mistake, wait a minute, I did spell it wrong, didn't I? Right here. I'm gonna make sure that I got it all spelled out. Let me see. It comes. What was I saying? It comes from temporary data structure. Like I keep telling you guys, there's the array. You got the hash map. Which is really array. And then you have this thing called the stack. This is just some, and then you have your queue. I think I spelled that right. I'm gonna make sure that I am spelling the part out. And then you have to deal with recursion, right, over call stacks, and how to use the intermediate buffers. And hey, listen. Don't worry, when we go through the breakdown, which I will be creating separately, you get to know what I'm talking about, because it took me a while too. And to select data, and to, because what happens is when you're going to go through the algorithm, you're going to say, but do I really need to use arrays, or do I really need to use something else, right? So you want to select the right data. Let me see. That's good. That's good. You want to select the right data structure. And then you have to consider the access pattern, right? Like maybe yeah, that's okay. We can say you have like the access patterns. This is the part that really drove me nuts, man, to tell you the truth. So, because you have to ask yourself that question: how will you fix, or no, maybe find or retrieve? Man, my legs are retrieve data. How would you do it? And then by positioning the index by the value or based on the relationship type, that's another question you should be asking. So it should be like by position, like which would be the index, right? The little index things in the array. Oh my god. By value, because remember the value pairs. Then you got or is it based on a relationship? So the arrays, right? Let me see. By index, right? Because that's how we do it, right? When you do something like that's whatever, you do something like, oops, like dollar. What you call it? I don't care, anything. A, B, C, and you go like this, and you say 2 like that. Let's bring this down. See, when you do this by index, that's what that is right there. So if you got like a dollar ABC with something like dollar ABC like this, and you have, let me see, ABC, DEF, 1, 2, 3, 4, 5, 6, like this. So remember, this A, B, C, that's a 0, so it will be this 0, and this will give you this A, B, C. If you say 3, if you say 0, 1, 2, 3, it will be 4, 5, 6, because they're always 0 index. It starts at 0, it's index. And you can use that hash table maps too by keys. And the trees, right? But let me write this down. We'll keep that there so that way. Well, I mentioned the ABC, right? By index, you can use the hash map table. Actually, just like this. Maps. And that will be by also key, right? I'll show you that when the time comes. This is just to get you thinking in your head, because you might want to go ahead and check some of these things out, right? Let's put this as on your own. That way you'll be more ready when you start doing. Then you got your trees. How you spell trees? And that's by what is it? By value pair. That's how you're gonna be using. I wish I had them. But we'll have some diagrams so I can show you what I'm talking about, and that's will be the relationship. I wish I had one of those things where you can kind of draw stuff. I had these things, but somebody canceled, and now I don't have it anymore. That was so upsetting, right? So, let's save this because we don't want to lose this stuff, right? Let me see. Let me show you. We saw that one. We saw that one. We show the constant time. We got the I can see. Comes next. Then you have ON. That's quicker. This one and this one are much pretty fast. This one is also fast too. Between those two, you know. And as we go up, we get slower. See how it's the yellow? See, first it was green, oh, fast. Well, okay, fast. I mean, you gotta do some things that we don't know what the end is. But then you start going into yellow, and then you got the purple, no good. Oh my God, it's terrible. Things will slow down to the point. And that's when you start doing, oh, sorry, this is slowing that stuff down. That's an ON. That's an O2N. Then you have your last one. Oh, that's the worst one. And it's mostly used for graphs and stuff. And then, of course, you have, what else do we have? The mutable size, right? The mutable size. Let me see. It should. YouTube. Slow size. I'm gonna bear with me for 1 second, guys. I need to take these things off. These slippers. Oh, it's killing my legs. I'm in the process of painting a picture for somebody. I gotta get it done quick. In a few weeks. Yes, I paint pictures. And then, of course, the mutable in size, and that would be like the data structure that needs to change in size, like to grow and shrink frequently. So you will have to ask your question, oh, will the data structure change? Write that down. You need to ask questions like, does the data structure need to change size? Because that's like growth. Let me write down. That's like growth or the shrinkage, right? When you take things out, you're gonna see what I'm talking about. And then you go. Oh my God, I can't believe it. It's so quiet. You know why? Because it's raining outside. Otherwise, it'd be so loud out here. And then you got your linked list, which I mentioned on the last video, maybe the video before that. We got the linked list, right? And all dynamic arrays, right? The array list or vector. See, the stuff that I'm talking about works for any language. But once I start doing the video, it's going to be for the PHP, you know? So the linked, let me write that down. The linked list, so dynamic arrays, like array lists or vector, okay, are good for changing size. And then you get your static arrays are fixed, right? Ooh, let's move this over. Matter of fact, I'll put it on the same line. How about that? So we'll say static arrays are fixed. Right? Stuff that don't change, like constants. And then you have, of course, the ordering, the order that you do the things. So you say you're ordering. Let me see. So that's another thing too. You have to ask the question: does the order of the element matters? Does the order of the element matter? It doesn't really matter to tell you the truth. Do you need to be sorted, or is the order irrelevant? It still doesn't matter. But if it needed to be sorted, that's going to slow things down if you needed to do something with the order of that list, right? So, as a matter of fact, let me just put that down there. And then you say, do they need to be sorted? Because if you do, let's say you're trying to go through a list because you want to get something. Now you're going to have to, oh, but we need a search. Now the algorithm changes because now you have to add more like something to get it sorted first before you start searching for stuff or something else, and that will slow things down. So I'm going to say, or is the order irrelevant. Okay. Let's save this because I want to keep. Wrong thing. Let's go here. I want to keep this for you guys because sometimes, oh, what was the whole company? I could go look at this, but I can also look at this. When I'm studying something, I want to see videos. I want to see paperwork. I want to see things. I want to see test results. That's just me. So you got your array lists, right? Arrays and lists. And that's like to maintain insertion, of course, order, or the slot index. And then you got this thing called a heap, and that's like for memory. Man, I don't know. I think I misspelled something here. Doesn't look right. Oh, yeah, I do right here. And then over here, I needed a slash. Really, this I don't know about being. Wait a minute. It's supposed to be here. And then you got your. Oop, I did it again. Can't believe this. All right. And then you got this thing called the heap. I don't know. I never had to worry about it because that's PHP. But when you're dealing with Python and those other things, if they have C and all that, they got this thing called a heap, and that's like to maintain a specific order of like the largest and the smallest elements. You call it the heap. I'm gonna write down here anyway. What did I say? Maintain the was it a specific order for the largest or smallest element? And of course you got hash sets, and I know it's crazy. Hash sets / maps, and now the order that often doesn't matter or isn't guaranteed, so you can use those. And then you have your speed, time, complexity, right? Which I talked about, how fast things go. So you got your. Let me write that down. Oh man, after I do this video, I'm going to have to lay down because take a nap because this is crazy. I've been sick for a while, even though I beat the cancer, but now I got problems. I'm going to have to get an operation on my both knees and possibly my spine. Oh boy, if it ain't one thing, it's another. Anyway, don't want to depress anybody. So then you have to ask the question, like, what operations need to be fast, right? Because everybody wants things fast. And then you ask you another question: is it insertion, right, or the deletion? Those things slow things down, man. Let me put that in next. Delete. deletions, or searching. That's another thing, because you're gonna be doing all this. You're gonna be doing deletion, insertion, updating. You're gonna be doing searching a lot. So you want to find what would be the best data structure to use. And you got stuff like, I know for a fact, we got the hash, which I've been talking about, the hash table, and that offers fast, like fast. Let me see, insertion, deletion, and searches. I should have wrote this differently. Because you don't want to check. So basically, you're going to be using something like the matter of fact, how about if I put it over here? I'll say O one. That's the fastest, and that's the fastest. Doesn't matter if you're doing 10 or 1,000 or million, because you're doing a quick search, boom, a quick the insertion, boom, fast. You start doing double, like looking for loops to do these things, fast. You're doing just double for loops against inside loops, then it starts to slow down. And if you don't know what n is, that's you use n is still fast. You use that one. But as you go on and on, things slow down. That's why you need to make sure you use the right data structure. I use a lot of the array stuff because, you know, stuff that I do, mostly, I use a lot of arrays. Then you have your, what is it? When you sort things, you sort in arrays. And then that offers fast search, that's for sure, but it's slow. It's slow insertion, and that would be not as slow as the other ones, but slower than O1. It will be something like O N, because you don't know what N is, and then you go like that. So maybe we should put I could say that is the, should I put it over here? Maybe I should just, because it's the, how about we do it over here? Because we are explaining. It's like the average O1. And then you have give me a second, guys. Alright, I'm back. Sorry about that. Alright. What was I saying? Slow insertion, right? That's all. And then you have your, and then you got to think about the relationships. Relationships, and then you have to ask that question: Does the data have a specific relationship, right? Like parents and child, or connected nodes? And that's when you start using like trees and other things. So, and you'll see that much later. Let me see. We'll say it here. You know something, a lot of this stuff, maybe I just tell you what I mean, and then I'll rewrite something, as long as I can remember what I said. Matter of fact, you know what I'm going to do? I'm going to hit my recorder. Give me a second. Okay, this way I can kind of start writing it down. I'll have it in my recorder. Okay, let's put it right here. And there you go. So that way I can have it, you know, done. But let me just finish up this thought though, because I did say it. The parent and child. And then, of course, you have your connection, right? Connected nodes. Let me explain to you what that is. So you got like the trees, right? That's the hierarchical parent and child, right? You got your parent on top and it goes down, and you got a circle, and you have a child, and maybe that child could be a parent of some other 3 childs below that one. Or you have your graphs. That's like many to have connections, because the graphs, you know, you do graphs and stuff like that, you're gonna have connections, like many connections to get to, and you probably will be using the tree. So you got your, so the common data structures and the strings. I like to say that the most common data structure when you should generally be choosing from is like you have, like I mentioned before, linear structures. You got your data structures, you got your array lists, that will be dynamic, and then you got your sequential access, and when you need to access elements quickly by the index, that's real quick, right? When you do, you know, like I mentioned before here, where is it? Like right here. This is fast. When you do this, this is fast. Doesn't matter if you got like 10,000. Once you pick, oh, let me see 10, let me see 12. It's fast. It's just fast. I'm gonna write all this stuff down, guys. Don't worry. I'm gonna write all this stuff down. Let's go to that first, this, and just keep it there. So when I'm speaking to you, and if I remember, I'll just write something that will be kind of fast. So I'll write it down. So when you do that, right, the sequential access goes so much faster, it goes quick, and you got your fast lookups, right? That the O1 by index, right? The O1. Matter of fact, I can just answer over here. But the O, that will be fast lookup. That's index. Remember, everything starts with 0. And then you got your linked list, that's singly or doubly or double. And then you have, what else do we have? I don't know. Oh, we got other ones like stack. I'm going to tell you in a second. When you need like frequent insertion and deletions at any position, that'll be fast when you use the O1. Because fast insertion, deletion, O1, once the location is found, it's an O1, because it's going to go fast. It really is. Notice how you write this thing down, write this, and you get it right away. That's fast. And then you got your stacks. We talked about stacks real quick on the other videos, but I'm going to break it down more on them because I'm going to have examples. So maybe I should put it down here. Let me see. I'm going to say stacks. I know I said I was going to give. Well, I am recording myself, so that's okay. If anything I miss out, I'll get back into it. I have the wife look into it because she's very good at, you know, typing and listening. And you got your last in and your first out. So anything that you add to a list of a table, because they're always going to get to the top part, it goes in first, right? But that's also the last one to come out. So let me see. First out, like that. These are stacks. Do this. Keep it. Don't trust me. Everything I have said here about this stuff, I'll make sure I put it on the file. Okay. So that way I'll write it up and then you'll have that whole thing. It's kind of like I forgot what they call that. If I remember, I'll let you know. So you got your cues, right? We talked about the cues. So we got cues right here. And that's also a first in, first out, like first in, first out. And that processing tasks in order for like job scheduling and searching and enforcing the FIFO, that's what they call it, access constraint. Then you got your key value mapping, like the hash tables and the maps and the dictionaries, hash map dictionary. I'm pretty sure you've seen that before if you've like been playing around with PHP. Storing and retrieving data based on a unique, like a key, and then an index, right? So extremely fast. It averages a not zero, or one lookups, insertion, deletion. Then you got your trees, right? It's efficient. It's efficiently what I want to say, searching and storing strings, especially for the autocomplete. Remember how you typing these kind of things that uses the tree data structure, and then you got your fast. Oh man, why can't I breathe? The fast prefix matching and searching, and then you got your non-linear structures, which is also, I'm telling you, this stuff is like very tricky. What else I don't remember? And then when they do the binary search trees, that that maintains data in sort order, and then it performs like the fast lookups, search and deletions. And then you got your heap. We talked about it, right? We got minimal heap. I know they got maximum heap. Efficiently finding the minimum and the maximum element for implementing these the priority of a queue. I know it's confusing. That's okay. Maybe I could suggest the book on old. I'll probably put it down to what book I was reading and got this information. It was like a green book and it was fat. Oh my god. Then it's the fastest, easiest to access the smallest and the largest item, or one, right? You got the peak and you got the O log n. And then you got for the graphs, right? The direct and undirected. And that's modeling relationship between the different items, like the social networks and the road maps and the flight paths. Because how you notice how you see it on the screen and all that is the graphics part that's doing this, and representing complex connections, solving path. Hold on, let me check to see if this is still doing my recording. Oh yes, it is. Path finding problems. So how can you determine your best choice? What is the best choice? So what I did was I did a list of a whole, what should I use? If I'm doing this, what is that? What is it, an O1? Is it I did that too. That's why I'm saying the separate videos will do that for you. So you have to determine, right? You have to figure out which structure is best for you. Answer, you have to answer like these questions in your head. You gotta say, but what am I doing most often? What is the searching is doing? Is it adding new data? Am I searching, or am I doing deleting old data? Right? And then you ask like, oh, does your data need to be associated with something else? If yes, is it a map? It's crazy. This whole thing is crazy. Is your data naturally set up in order for like important connection, or is it connected in a complex way? If yes, then a tree in the graph might be what you need, right? And in the next video, I will break down each and give examples of what I want to say about these trees, about the data structures, and what each one, like the arrays or one, what the tree is. I'm going to break it down, that way you can have it. This was just a quick, discussion, and I'm going to put it down because I did record it. And let me stop it right now since I'm going to finish up right here. Good. And then, and that's it. Basically, I wanted just to kind of introduce a little bit. I will have this thing set up. It will be in the description below. So on the next, we're going to break it down, give examples, and so you can see what I mean. I know it's confusing because I was confused too. It was just like, oh my God, this is crazy. But anyway, it'll be good. You're gonna start looking at it. And then when you start knowing this, you're gonna start looking at other people's algorithm. You're gonna say, oh yeah, look, it's that's not an O1. I mean, that's a, I don't know. That could be an OL log 2 or the power of 2 or all these little things. You'll see what I'm talking about. Anyway, because right now I'm stuffed. I'm gonna have to cut this video right now. Kind of came to the end anyway. Then I don't know if you guys celebrate Thanksgiving or just want to wish you guys happy Thanksgiving. And so we reached the bottom, right? If you can just give me a like and subscribe, give me some comments. Let me know if I'm doing something wrong, if I got you confused, because I'm pretty much sounded like I was getting you confused. But I'll have it all written down, put it in the description, that way you can have it. Okay, guys, so we reached the bottom. Like I said, have a happy holiday, a good night.